Now that we've created our FE model, we need to create the other input for our analysis, boundary conditions. You can continue working in the nTop file from our previous lesson. To this heatsink model, we'll apply 3 boundary conditions. First, a convection boundary load to the surface of the heatsink where heat transfers to the surrounding fluid. Second, a radiation boundary load where heat is transferred from the heatsink via radiation. And finally, we'll add a temperature restraint to the base where the temperature will remain at a constant 373 Kelvin. We can begin with this temperature restraint. We can either search temperature restraint in our search bar or find it under the Simulation tab in Boundary Conditions. For our temperature, we'll want to apply our hot temperature from our inputs. And for our boundary, we'll want to select the bottom of this base. We can add an FE boundary by flood fill, choose the FE mesh of our base, select nodes as our entity, and drag the gimbal underneath this base to select our origin. We'll leave the angle at 45 degrees. And now we've created a constant temperature at each of these nodes. I'll make this a variable and call it FE temperature. Now we can add our convection boundary load to the heatsink. I'll start by pulling in a convection boundary load block, which can also be found under the Simulation tab. And I'll have to apply an ambient temperature of the surrounding fluid, as well as a convection coefficient. We can pull both of these from our starter file's inputs. And for our boundary, again, we'll use the FE boundary by flood fill. We can use the FE sink as our mesh. We'll select faces. And we'll drag our origin to above our heatsink. We'll play with the angle a bit to select as much of the heatsink as possible. And choose all of these faces. Viewing the convection boundary load, we can view the load applied to our surface. I'll make this into a variable and call it FE convection. Finally, we'll create our radiation boundary load. I'll go into our boundary conditions, pull in a radiation boundary load, and I can copy and paste the boundary from our convection block into our new block. Here, I'll apply the ambient temperature, and an emissivity value between 0 and 1. I'll make this third boundary condition into a variable called FE radiation. Finally, I'll drop all 3 of these boundary conditions into a boundary conditions list. I'll make that list into a variable called boundary conditions. And now we've finished creating our boundary conditions and can move forward in running our thermal analysis.